Hello, my name is Richard. I am a student from Sekolah Programming Indonesia, and I'm going to teach you about Anaconda Navigator and my project. In the Anaconda Navigator, you can create a new environment or delete an old environment, but it's going to be super slow. Instead, we're going to use the Anaconda prompt. And to check the environment list, we can just go conda environment list. This checks all the environment that you have, old ones, but instead, we're going to create a new one. You need to go conda create dash dash name, anything you want. We can go SPI Jakarta. That's okay. We can just go Python equals equals. We're going to use 3.9 because we need 3.9. Okay, it's going to create. We're going to type yes. Okay, we're going to have to make sure that it is created with conda environment list. Oh, as we can see, it is already created. We're going to activate it with conda activate SPI Jakarta 1. Okay, it's already created. Now time to connect the path from the folder. I'm going to use recent prediction HTML. Copy it. Oh no, not copy it. Copy the path. Copy as path. To connect it, you can just type cd and then the folder. Delete the quotation and then enter. As you can see, it's already connected with this environment of SPI Jakarta 1. To open the code, we need to just type code, space period, and it'll open my Visual Studio Code. As you can see, there's two HTML, dashboard HTML, login.html, and sign up. We also have an app.py, and this is the CSV we're going to use today. This is the training model that we're also going to use. This is the JSON file to store username and password. To see what we need to install, we can see here, we need pandas, numpy, and stri.learn. We can just run it. There we go. pip install pandas. It's going to take a while. Okay, it's done. pip install. Should I get learn? There we go. Installing. And you want to make sure there's no warnings on the file. Okay, now I'm going to explain the code. This the CSS file, and of course connected to all the HTML to make the website prettier. And on dashboard, there's everything. There's the header. It's going to have a logout system too. This is the main. It's going to have a form. It's going to ask about the name, income, credit score, and etc. This is the footer. The footer is going to have information about who I am and my name, the place, etc. This is the login. The login is simple. It's going to use data from the user.json and make sure that it is already in JSON. If not, it's going to be sign up. You can sign up. It's going to ask for your name, username, and then password. And then the password will be stored in user.json. In the app.py, this is where it asks our username, password, and also the model, the age, income, credit score, credit status, and the logout. On the model.train, this is where I already trained my model. It asks for age, salary, credit score, and status credit. And this is the pickle. I'm going to start the file with a simple space Python app.py. Oh, Python app.py. Oh, might be just. Oh, yes. Flask. I forgot to install Flask. Well, it happens. Like I said, make sure there's no warnings. We can start with Python. No, we need capital Python. Make sure it's correct. Python app.py. Okay, it's going to give us a link. We're going to copy the link and go to your browser. I'm not going to use my normal browser. Instead, I'm going to open a incognito tab because it doesn't save cookies. We can paste it, and it is my website. It's going to ask for, if you don't have a username, you can sign up here, or if you can log in, you can just put it here. But instead, we're going to sign up. We can use it as admin and 900. Oh, 900. Sign up. As you can see, if we go back here to user.json, it is saved as admin and 900. We can go back to the website, admin and 900. Oh, maybe I'm wrong. Admin 900. Does it fight anything? Maybe it kind of fights just deleted. Maybe just something simpler. Richard and then SPI. Sign up. Richard and then SPI. Okay, there's my machine. It's named the Credit Data Machine 9000. This is where it can predict yes or no. Let's enter 25. Salary is 9. Oh, sorry. Salary is 9. Credit score is 76. No, come on. 76. Credit status. It's going to be good. And we can predict. And it's going to predict, oh, give credit. This guy has good salary, credit score, and of course the machine is going to say give credit. And this is the header. This can be your contacts. This is like the company name. And you can log out. Well, when you click log out, it's going to go back here.
So the question is, Richard, how if the user is not worth to get the credit? Can you give me the example and also the simulations?
Mm-hmm.
In case if the user is not worth to get credit, right?
Which you can go back Richard, and then I already forgot my password. SBI. We can log back in. Let's go that he is 19. Salary is 23. The credit score, let's say 10. The credit status before, he never paid his debts, so it's bad. Now let's predict. Of course, the machine's gonna say no credit because, of course, he has a bad credit status before, a credit score, a horrible credit score, and a poor salary. And of course, the machine's going to predict no because it's the only logical way that he's not gonna get any credit because of the previous time. What?
Okay. Can you explain to us about the process when you made it, right? I mean, when you made group, I think the mason can predict, right?
Mm-hmm.
How you made it? How can you made it?
Mm-hmm.
From where? From the
Okay.
model or from FDPY?
Mm-hmm.
I look at your previous code, your previous on the VS code, there is many files, FDPY and also the model.py. What is the difference?
Okay.
And look at that, there is a block PL. Where you get it?
Mm-hmm.
Okay, where you create from what? Okay, from the data or from where? Okay.
Okay.
Can you explain it to us?
We can see in the Visual Studio Code, the model.train.py doesn't ask anything. It is only some codes to make the prediction for the model. So as you can see, it doesn't ask your age, your salary, and this is the pickle file. It doesn't ask anything, but instead it creates the prediction system. You can see the CSV right here that we have, the credit chance, yes or no, and it's going to ask age, salary, credit score, status, credit, and credit chance. Instead, if you want to see the question, we can go to app.py over here. There we go. This is the predict motion. It's going to ask age integer because of course age is a number. Income is also an integer because it's going to ask about a number. Credit score also an integer because it's going to ask for maybe 1 to 100. Input data is going to this the input data is going to add age, income, credit score, status, and text. This the credit status. You can choose 1 is good and 0 is bad. And the result you can get yes, give credit or no credit.
Okay, and look at this one. There is two code, right? There's app.py and also model.py. So my question is this one, Richard. Or what is the difference between app.py and also the model.py? Because there is the different code, yeah. There is a different typing, there's different prompting. There's two code in there's two file. What is different? You use app.py for what and the model.py for what? Okay, yeah.
Well, as you can see, the model.py contains almost everything we need to make a prediction. We have load dataset, map categorical text to numbers, a feature selection, train.split test, train the model, evaluation accuracy, but it has zero about getting information from you, the user, like the age, income, or status credit. It only been asked in app.py. In app.py, you can also see over here it has a flask. It's going to ask about your flask, load users, define safe users, the app route, there's a login, sign up, log out, and it's going to also ask about your age, income, credit score, credit status, and then you can see it in dashboard.html. It also asks this. Oh, it's gonna have a age, income, credit score. It's connected. We can see with the pickle.
Okay, and look at this one in the model train. Can you open it again? I have a question, right? Um, how can you make this code? There is a flow when you make this code. I mean, okay, another one is that then after it you keep the explanation, simple explanation, map category call text to number, then feature selection, train or test split, train the model, evaluate. I mean, you build the code like that.
Yes, that is
What is the basic why you type this one? Can you explain about the flow when you made it? Yeah.
in the common flow when in data science. It's first data acquisition, as you can see here, or you can see library first. In data acquisition, we can clearly see that it takes data from the CSV that we have here, data credit.csv, and this is going to use pandas. And in this time, this is the data credit chance. It says yes or no. It's going to predict. If it's 0, it's a no. If it's 1, is a yes. This is going to be a feature selection. It's going to ask about age, salary, credit score, status credit, and Y is going to be the prediction for the machine, either 0 or 1. This is the train extras just to train the data about the thing we need. There's the model, the evaluate accuracy, and this OS, the pickle file.
Okay, and look at this one. I look at the trying the model clean network classifier. I have a question. So when we want to make the AI project, the model of the AI project, so we have to use key network classifier for every code.
No, 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 no.
So
In this code, I use k nearest neighbors because it's the only code we need. We don't use any other because it'll just break the data. In this particular CSV, it needs k nearest neighbor because we want to find a particular prediction, yes or no, because that's why it uses the k nearest neighbor. There is a lot. You can use hierarchy or many more different tools.
so upon the model, also the key network classifier, when we make the AI, yeah, not always we use key network classifier, right?
Mhm.
So we have to choose the model that suitable with our data set. Right?
Yes.
Oh, like that. Oh, I see. Okay. And okay, good job. That's so good. Okay. Well, thank you, Richard, for the explanation. I
Okay.
already know that. I have a question. You are running Python app.py, but what will be happen when you are running, yeah, when you run Python model train.py? What will be happen?
When we run that, it'll just add another pickle. We can also go to terminal, or we can just go to model.train.py. We can also run it here.
Can you show it to me, Richard?
We're going to activate it. Let's try model, no, Python model train.py. It's not going to do anything because it is not the right code. The code is in app.py because the Flask is in there. It's going to ask for app.py because app.py activates everything, the HTML, the JSON, the CSV, and also the model.train.py is already in a pickle. That's why we don't need to run it again. We can actually delete it because everything here is already in the pickle.
Okay, thank you, Richard, for the explanation. And I think you already made another project, right? Can you say it to me also?
Oh yes, we can see I have created the Python sign prediction. There's also a coffee shop place, but I don't think I finished the coffee shop place.
Okay, can you say to me about your previous project that you already made it?
I've already made a lot of projects in my collab actually. My collab, let's see, open here. Google collab. There we go. As you can see in my Google Drive, I've already learned linear regression, deep learning, neural networks, and then non-hierarchical clustering, many e-commerce tree project, in image lab project, startups, many. I have already learned a lot.
Okay, and you said you already made the recent prediction also, right?
Yes, resign
Can you show
prediction.
it to me?
The resign prediction. Let's open it. We can just close this one. It almost uses the same tool, so we can just delete this one. Let's open back our Anaconda prompt. This is the file, resign prediction. Let's copy it. So you're gonna go Conda environment list. We're going to use the same environment, Conda activate by Jakarta 1, and then connect it with CD. That should be correct. It's already connected code. Here we go. It has the model, static, the logo, index of HTML. Okay, since we already almost have all the tools, we can just open here, open our Python file. There we go. We can Python app.py, and it will give us let's see. Hello, my name is Richard, and today we're going to open the Anaconda. The Anaconda prompt, we can just open here, close this one. Oh, that's a PowerShell. Okay, let's open it again. Anaconda prompt. Let's create a new one. We can go Anaconda, create, name, dash dash. We're going to name it SPI, resign. Hopefully nope, I don't SPI, resign. And then Python equals 3.9. It's going to create. Oh, no such thing. Comment error. Create. Anaconda. Let's just copy this. Control Shift C. We can just go back here. Conda create. Oh, maybe there's no space. Shift V. Conda create. Name person. SPI resign. Python 3.9. Still correct. This is still correct. Oh, maybe let's see. You can go to file, go to documents, copy the resign prediction, copy as path, conda environment list, conda activate, SPI, resign, okay. Oh, conda SPI, resign. Conda activate conda. Okay, and then CD, go to Shift A, delete the quotation, and then code period. We're going to open app, PIP install. Let's see, Flask equals to 0.1.3. Let's see. Okay, PIP install 1.21.6. Not in PIP install numpy 1.21.6. Maybe numpy. Oh, PIP install numpy equals 1.6. Maybe no space. Just copy it. Numpy 0.6 PIP install equals 1.26.6 PIP install check it equals 1.0. Okay, Python app.py. Oh, it's still error. Let's see. Import. Let's see. Let's make sure. App.py. There's no CSV. Nggak ada CSV. Thank you. This is my presentation. Thank you for your time. Thank you.